Welcome to Phase 4, Video 3. So far, we have learned how ML models are used and what deployment really means. Now it's time to answer a very practical question. How does a machine learning system actually look in production? Not tools, not cloud dashboards, just architecture. So this video is about structure, not technology. Once you understand structure, tools become easy. So let's move on. So purpose and importance of ML deployment. Well, machine learning deployment architecture refers to the structure framework that enables trained model to be integrated into production environment for real world use. Its purpose is to ensure that models deliver accurate prediction at scale, maintain reliability, and adapt to changing data condition. So let's understand the core components of ML deployments. Data sources and processing layer. So data sources, every ML system starts with data. For example, databases, logs, APIs, and user events. So the key line is bad data architecture breaks ML systems early. Now we will understand data processing layer. So raw data cannot be used directly. It must be cleaned, transformed, and validated. So the key line is data processing layer decides model quality. Now we will see model training and artifact management. So model training is the process of feeding process data into algorithms to learn patterns and make predictions. This involved selecting appropriate models, tuning hyperparameters, and validating performance using metrics. Training can occur on local machines or distributed clusters, depending upon data size and complexity. Once a model achieves satisfactory performance, it is serialized into an artifact for deployment. So, a trained model becomes a model artifact. It is a file or package. This is what gets deployed. So the key line is you deploy artifact, not notebooks. Now, serving layer and monitoring. So serving layer is responsible for making trained models accessible to application and end users. This is where predictions happens. For example, API based prediction, batch based predictions, streaming based predictions. So prediction must be monitored. Performance can degrade, data can drift. So the key line is ML system must learn from the real world. So we will understand architecture flow and real world examples. So end-to-end architecture flow. And end-to-end ML deployment architecture begins with data ingestion from multiple sources, followed by pre-processing pipelines that clean and transform the data. The processed data feeds into the model training environment where algorithms learn pattern and generate predictive models. These models are then serialized into artifacts and stored in a version control repository. The next stage involves deploying the model into a serving layer, typically using containerized environment for scalability. API expose the model to applications, enabling real-time or batch predictions. Continuous monitoring system track performance metrics and detect anomalies. So case study, let's understand, think of a recommendation systems. User action generate data and data is processed, model is trained periodically and predictions are served via APIs and clicks are monitored. So this is a real example, real use case of living systems. So key insights are ML is not one time task. It is an ongoing system, and engineering efforts should never stop. So the common mistakes are focusing only on model accuracy, ignoring data pipelines, no monitoring, no retraining strategy. So the key line is architecture failures causes ML failures. So why tools comes later? Well, cloud tools implement this architecture, but tools changes. Architecture principle do not. That is why tools comes later. So in summary, ML deployment architecture is a multi-layered framework that transforms trained models into operational assets. It encompasses data sourcing, processing, model training, artifact management, serving, and monitoring. Now that we understand architecture, in the next video, we will connect this to real deployment choices. So see you in the next video. Thank you.